Hi again. Welcome to this video, the first of two, on the concept of discrete random probability distributions. This first video summarises the main concepts of this part of probability and shows how to interpret the ideas. The first concept is that of the random variables. Most research investigates a population or a subgroup of the population with the aim of examining a particular characteristic of the members of that population. For example, we might want to do a gender analysis. We might want to categorise people by their racial origin. We might want to categorise people by their age or by their income. Data are collected on the variables we define as being of interest, and so the data are the observed values of those variables. So what are random variables? The Macquarie Dictionary defines random as being not according to a pattern or a method. Synonyms of random include chance or undirected. Using these ideas as a base, the term random in probability and statistics implies that a selection of someone or something to be studied is not done with an intent or a deliberate purpose related to that person. Instead, each person or object to be selected has a defined but unbiased probability or chance of being selected. Sometimes, of course, we do not want a sample selected on the basis of randomisation. For example, if we want to study the effectiveness of a new treatment for burns, or the effectiveness of a new cancer treatment, or the attitude of students towards Year 12 studies, we do not want to select people having an equal or at least a known probability of being selected. We then want a purposive sample of people selected because they must have the characteristic being investigated. Hence, the criterion of randomness aims to maximise the probability that a subset which is selected reflects more accurately the characteristics of the broader group or the population. Randomness, therefore, minimises bias in the sample selection process. With such a perspective, random therefore implies made, done, happening, or chosen without a predetermined method or a conscious decision. The next concept is that of variables. In algebra, we are always using the term variable. It is a quantity represented in an equation by a letter or by a symbol to describe a relationship amongst the unknowns. Equations are written to show how the value of one variable depends on the value of another variable. If we use a function, then we can substitute any values for the independent variable and calculate the value of a dependent variable, which was the subject of the equation. So the concept of a variable in ordinary algebra is different to the concept of what we call the random variable in probability and statistics. In the probability and statistics fields, the term is used in a much more abstract and varied way. So a random variable is a variable having a probability distribution associated with it, or a function that assigns a numerical value to each of the number of possible outcomes in an event space, quite different to the ordinary algebra interpretation. A one-dimensional random variable therefore consists of a finite set of values for a given variable, that is, for the characteristic to be investigated, and each of the values reflect the probability of each aspect occurring or being selected. So, unlike in the algebra context, the random variable in statistics has a set of values intimately and directly associated with it. A random sequence of events, symbols, or steps has no preordained order and does not follow a predetermined pattern or combination. For the dice example we were talking about earlier, there is no sequence of numbers known in advance, unless of course you are cheating. There are two types of random variables. We call these discrete or continuous. A discrete variable is a variable whose value is obtained by counting occurrences. A continuous variable is a variable whose value is obtained by measuring. So a discrete random variable is a variable representing numbers which we find by counting things. For example, we might want to count the number of marbles in a jar. We might want to count the number of students who are present, or the number of heads when tossing 2 coins. The probability distribution for each of these examples contains all the possible values of the random variable and the probability associated with each outcome. So what does a discrete probability distribution look like? Well, first we have a table. We have numbers in it and normally just 2 rows. On the top row there is a variable with discrete values, so we're going to call the variable x in this case, pretty common. On the bottom row, for each value of the variable there is a probability associated with that variable. Because the probabilities associated with the variables complete the whole set, then the sum of the probability values must always be equal to 1. Just by using the table itself, we can read off the probabilities as we usually do. For example, in this table, there's a 10% probability of the number 4 occurring or being selected. We can also see that the probability of selecting a number less than 3 must be 0.7, 0.4 plus 0.3, and so on and so forth, just the normal interpretations. There's quite a number of questions which rely on the fact that the probabilities must sum to 1. So a typical question is the table I've got here, in which the probabilities are 0.2 for the variable value 1, and then p, 3p and 0.2. The question asks you to find the value of p. Well, the probabilities must add to 1. So therefore 0.2 plus p plus 3p plus 0.2 must equal 1. 4p equals 0.6, p equals 0.15. Very easy questions in this regard. There's very, very few that are hard. Some of them depend on arithmetic series, and you can come and try them after you've done that particular topic. So these are the main concepts you need when you look at a table giving a discrete random variable distribution. In the next video, we review the concept and calculation of values to be expected for a particular random probability distribution. We also determine how variable the results might be. Go and do some test yourself 1 questions on my website, drjoesmaths.com. Hit the like button and subscribe if you haven't already. Then you get notification about new videos. Good luck. See you in the expected value video shortly.